Today we'll be talking about coding agents and how to evaluate them honestly.
I have a very non-traditional background for ML research. I'm a dentist by training. I attended NeurIPS in Vancouver, and Ilya Sutskever had his speech. He asked me about attention. I'd never heard about it.
What is different for you in this tech world comparing to the world of medicine that you were trained on?
The price for error is really cheap. It was like tough to change my mindset, to switch to the mindset that you can just do errors.
Will AI replace programmers? Will there be more programmers, but some different programmers?
If this guy can beat me so hard in ML, I can learn something from that.
Basically, you are doing reinforcement learning for yourself.
Yeah, exactly.
Hey, this is JetBrains Research Podcast. I'm Igor Slinko, and with me is Ilya Zakharov. This is our second episode. Today we'll be talking about coding agents and how to evaluate them honestly. Our guest is Ibragim Badertdinov, lead research engineer at Nebius, first co-author of SWE-Rebench, a benchmark and a dataset with 12 million downloads on Hugging Face, accepted to NeurIPS 2025, and over 1 million leaderboard visits a month. SWE-Rebench version 2 and contree.dev are both dropping this week, so right now we're in the middle of fresh news. Ibrahim, welcome.
Yeah, and hi Ilya, hi Igor. Yeah, thank you. Thanks for having me.
Quick context for everyone to this space, coding agents and everything that you heard of for the last couple of years. So these are AI systems that work autonomously and they solve real programming tasks, reading code bases, understanding the issues, fixing the bugs, running tests. And in 2024, top models solved about a third of standard benchmark tasks. A year later, over 70%. But it turns out measuring that progress honestly is really hard. Benchmark leak into model training and the number starts lying. OpenAI just announced that they are dropping SWE-Bench Verified, which was the golden standard before, and it will use another leaderboard at whole. So SWE-Rebench is one of the answers to that problems. And before we get into the benchmark, Ibrahim, tell us about yourself. You're now lead research engineer at Nebius. That's one path. The parallel path is a medical degree and dentistry. Right? How did they intersect? And can you tell us from the beginning, who were you before ML research and how did you get?
Yeah, sure. So my name is Ibrahim. I'm based in London and I'm doing research at Nebius. But yes, I have a very non-traditional background for ML research. I'm a dentist by training. I have graduated with honors from Kazan State Medical University with degree in dentistry. And I also have completed a residency program 2 years in healthcare management and public health as well. For me, like when I thought about my future profession, I thought just medicine is the most interesting domain that you actually can learn because you learn yourself, your mind, how your body works, and it was really fascinating to me. And I also thought that actually it has a really huge social impact. So you can just help people, you can help with them with their pain. And I also thought that in the medicine, there are several specializations. And for example, dentistry is great because it is really well paid. You can earn a good amount of money and it's not that high risky. And also dentistry has a really high barrier to entry. So you can't just come from the street to dental office and start working. You can't just take a few online courses and go to this domain. So like I was 18 years old. I thought, okay, I can try something with medical university and then decide something else. Because in 18 years, I thought maybe I can try something with math or like tech, but I can't really go into medicine in 25, in 30 years old. It will be much harder than just doing medicine now when I'm young and then make some kind of transition. But to be honest, like first and second years in medical university was really great. You just study anatomy, pharmacology, all the disciplines. It's really interesting. Your like lessons is not just sitting at the desk and reading the books. You go to the hospitals, you do all the practice. It's really like great years. I have gained a lot of valuable experience, a lot of life experience. But then something like fourth year of study, I thought that I can try something else outside of the medicine, because all of my friends were working in dental offices. But I thought that if I will start working as a dentist, this will be my life. I had like a lot of years to work with patients. Maybe I can try something else. So I tried a little bit of events organizing, a little bit of marketing, a little bit of parties with my friends, tried to do some commercial stuff. And I just thought that maybe I need to try something more challenging. And one thing that I thought of was that in dentistry and in medicine, you gain a lot of skills that are not really transferable across the domains and professions. So if you start working as a dentist, after 10, 15 years, you will want to switch your profession. You basically will have to start from scratch. You will need to gain respect, all the skills. And I thought that like in tech, for example, you can actually gain some skills and some kind of tool chain that is transferable across domains. You can work in different domains and try to build your projects. So I thought, okay, I can give myself one just a gap year, try something else, maybe with tech. Just the main goal was to gain some new skills, not in the medicine. That is why I actually started my residency program, because you have more free time, so you can just do something else besides the residency. And I thought that, okay, I will give myself 1 year, and if everything will be good, I will start and do something else. And if not, I will just go back to the dentistry and start working, earn money, and just live my regular life. But actually, yeah, I gained some skills, and it was like life-changing experience to me. Actually, tech after medical experience, after like medical university and medicine, I enjoyed it a lot.
How hard was it? Like I cannot imagine how to switch this to jump this high.
Like medical universities, I think it's something in between like STEM, like math or physics, and something like sociology, I don't know, legal, and other professions. Because in medicine, you don't need to work a lot with abstractions, I believe, like in math, but you need to actually memorize a lot of information and try to build some kind of relation between domains, between information, a lot of system, because every subject in medicine actually learns same thing, like our body, but in just another layer. For example, on the layer of the cells or tissues or genes, or maybe just about diseases, some systematic failures, anatomy. So it was mostly about systematizing your knowledge and everything like that. But after that, when I tried to switch, actually, I enjoyed that in tech, you have a very fast feedback loop. So when you write the code and then run the test, you just see your errors. You can work on them. In medicine, that's not how it works. And the price for error is really cheap in tech. Like then I started work and my colleagues said, oh man, we just dropped the database. It's insane. They were so nervous. They were so mad. And I just, man, you just need to reboot. Maybe, okay, you will do something like 1 hour extra work, but it's nothing compared to like medical practice. I had a practice 1 month in oncology and big hospital. It's really a tough place. 2 months in like pediatric dentistry, working with childs, insane experience. And when also 2 months in just a regular dental office. And for me, when I compare it, it is actually not that hard. But I need to say that my medical education really helped me a lot to make this transition, because I remember that my overall maybe experience and skills about how to learn some new concepts really helped me a lot. And I also, like, it was 2018 when I completed my like a medical university. I started trying to gain some CES skills through the project called School 45. It actually, there is a school called L'École 21 in Paris. It has a lot of offices across the globe. The main methodology is that you actually can't really teach people by just showing them some lectures or videos. You need them to do something else. So there are not any books, any lectures. You every day you just get some exercises and you need to do them. You just search the web, ask your peers, and you try to build the project, iterate through the feedback loop, write code, get the errors. And it was really strict, but in just 1 month of this program, it even wasn't the main program. It was just some pre-program 1 month, like a bootcamp. Just actually, it was, I think that the most intense month in my life in terms of gaining new knowledge and skills. Because every day, starting from 8 a.m. till, I don't know, 10 p.m., we were grinding. A lot of persons, like with notebooks, just grinding, writing code in C, dealing with mallocs.
The joke about learn C in 32 days now comes to
yeah. And after this month, I thought, okay, actually, that's doable. Because before that, during my 3rd or 4th year in medical university, I thought, oh, it's like so complex. I've heard about data science something. And I thought, oh man, if I had an opportunity to like study, it's for some physics or math, maybe I can try something like that. But after this 1 month, I thought, okay, I can try, at least try. And I mean that, I think that at this point, I started really believing that I can do something in the tech field. And I thought that I don't want just write code on the backend side or databases. I thought that if I have some like medical experience, maybe at one point I will want to do something in between medicine and tech. So I thought that AI is like, back in the day, it was called ML, not an AI, mostly about machine learning and data science. So I thought that I can do something with that. And I asked, there were a community called Open Data Science, a big one, and they had like a free courses, ML course and DL course.ai. Okay, that was like first course that I saw. I took them, and then I moved to Moscow, into a city called Dolgoprudny, it's town, and there is based a very famous physical technical university.
Yeah, I was learned in this.
Oh, great, Dolgoprudny. Yeah. Insane place, actually, Dolgoprudny. Yeah, I lived in Dolgoprudny for 1 year with my friend, and I went to. I actually took several master's courses in deep learning because there were just an opportunity. I also took some courses from like Higher School of Economics because they also had like this program. I just found persons that taught these courses and wrote them. Can I just attend, just listen to something? And I was really shocked that everyone just told me, okay, no problem, just come and listen. Then I came there, listened, and I heard about the training also. It was called something data mining connection. I think something like that. There was a person, his name is Victor Cantor, and he had like several courses. And one course was like basic machine learning. The next one was industrial machine learning. And I thought, okay, basic machine learning, actually, I can just took some online courses like Coursera and something like that. But industrial, it's not that knowledge that you can just do online. But they had a really actually hard entrance, some exam. So I needed to pass like math test, code test. So I just Googled data science master's program, and they had questions for the entrance exam. You have linear algebra, math optimizations, statistics, and list of questions. Then I just Googled every question and just greened it with the resources. I mean, nowadays it will be a lot easier with the LLMs and all the system. But back in the days, just Google YouTube videos, 3 blue, 1 brown YouTube videos, ML courses. It was like one grinding month. Then I've heard about Kaggle, like competition platform. And I thought, okay, I need to do something in practice. Everyone are still learning C. I thought I'm not going be a C developer. So there's a Python in ML. Python after C was something like you just speak English and code is written. So I started doing Python. I started participating in Kaggle competition, and there have been some. There were going competition in NLP. And actually, I believe that Igor, you had a course on Stepic on computer vision. Yeah, I actually took this one, and after that, I started like Stanford 224 and stuff like that. But your course was actually the only course on computer vision that I took, and I used this information to win one hackathon with the CV project. We used phased vectors to scan your face, understand is it like a rectangle or triangle shape, and then recommend you some sunglasses with the format. We won the hackathon with this information. So I know Igor from 2019, I believe. And yeah, that's how actually after one competition, I had several interviews because when you win some competition from the company, they actually have an interview with you. And I had 2 offers after the interviews. First one was easier interview, just basic ML theoretical questions and a very small lead code style task. And the second was the interviewer just, I think that he asked me something like 50 questions and I failed half of them. He asked very specific stuff. He asked me about attention. I'd never heard about that. Yeah, I've heard about attention, but asked me about attention, all the stuff, really green. And I thought, okay, I failed it. I thought that I failed it because in medical university, you need to answer 18% of all the question, ideal to just pass the exam. I thought that I failed, but then they actually asked me to come once more, and then that's how I get my first internship. And I thought, if this guy can beat me so hard in ML, I can learn something from that. And he was one of the greatest mentors that I had. He actually was the person who trained in the late 2018 BERT model for Russian from scratch by rewriting their open source code to run on the Google Colab TPUs because they had really generous limits back in the day, and then just used Google Cloud as storage for the checkpoints because you can train only for 4 hours. So he wrote the loop that train for 2 or 3 days and get the model that just actually beats every other LSTM-based model, every other NLP model. So that was how I actually get my first internship, how I gained some ML knowledge and skills. And yeah, I think something like that.
Fascinating. Actually, we're just skipping through like 10 questions that I had to you. You're just answering them somehow. I'm very glad that we actually met before when you were like listening to my course, because like every time that I go and check the course and I see like bigger numbers of attendees, like I don't know those people, right? I see some reviews, some comments, but I like usually never know exactly the persons who are attending this course. Yeah.
I was just the question. I also came to this field from a different area. I was a psychologist before, and for me, the question is: how do you see this world of software engineering and ML? What is different for you in this tech world comparing to the world of medicine that you were trained on? What was the shift? What was crazy in the way people think in this world? Are there anything that you was feeling as an outsider that you like see where you belong, what is nice, maybe what is not nice, because it can be very different?
Yeah, actually, it's a really great question, because I had a life-changing experience with tech. For me, it was just really mind-blowing, because like in medical university, I lived in a small room in Kazan. I woke up every day at 5:30 a.m., just cook my breakfast, 1 hour to go to the hospital, so you will be there at 7:30 a.m., then study until, I don't know, 4 or 5 p.m. Then I also needed to earn some money, so I had several like work opportunities. I worked a lot, like every day, just grinding. And medicine it's a lot stressful actually when you go to the practice, because, for example, in dentistry, every day, something like 20 patients come to you with some pain. They're really nervous, and you need to help them. And it's quite risky. It's not that easy. It's really stressful and draining experience. So in contrast, in tech, there I start my first work. Just you come to office at 11 a.m., maybe something like that. You don't need to set an alarm. You just talk with people. It's not that nervous. And it is great. You can work remotely. It actually great in terms of some kind of overall experience, because in medicine, it is called paternalism. Then there is a lot of authorities, so you can't just speak loudly your opinions. You need always to listen to the authorities, not only respect, but you can't really, even if you will give a lot of arguments, in some argue, actually, if the person have a higher position or just elder, you will listen to him. So, and also it is a field that is not that fast changing, and it actually makes sense because it's medicine. The stakes are really high, and price for every error is really, really high. So you can just do all the stuff and do a lot of experiments. And in contrast, in tech, you just experimenting. And in the machine learning, in AI, like this domain is accelerating really fast every month. I've seen, like my first internship was in NLP. I worked at the team that were doing virtual assistants, chit chat models, and question answering models. So basically fine-tuned BERT model for information retrieval voice agents, and also GPT-2, like GPT-2 for like chit chat modeling. Back in the days, 100 million of parameters. I started working in 2022. I thought, okay, we will see, maybe try something else and other domains. And for me, the contrast was like, for me, it was easier experience working in tech, and you can earn more money at that time. It was quite interesting for me. It was really mind-blowing that some of my superiors, like managers, were really young, because in medicine, you can't just pace through the career ladder so fast. And also, I really liked it that you can, if you know how to write code, you actually can do anything in any domain I work with voice assistants. I work some medical projects, recommendations, creator sequence, software engineering. You can try a lot more than just doing some deeper specialization. And in terms of like working atmosphere, for example, when I had my first, we were using Scrum and Kanban, and there is a like meeting called retrospective. Then you just give your opinions, what was good, what was bad, like maybe something about communication. And during my first retro, I just heard that someone told another engineer that, okay, I had this pull request review, and you just sent me a comment about bug fixing, and I think that it was a little bit passive aggressive. Like you, maybe you can just write something like "please change." And I thought, for me, it was insane, because then I worked in like hospital, and you're like a nurse, and main surgery guys, or they just speak with you with very loud and obscene lexic. And for me, such soft communications was like, I was just sitting and smiling. I thought, it's really how you work? Like, is it that comfortable? We even like had coffee, like gym, pool. I thought it's insane. I don't need to pay. You pay money to me, and also give me these opportunities. And for me, it was an insane contrast. But I also really like this part with the working in tech and in ML, that you can, for me, it was like tough to change my mindset, to switch to the mindset that you can just do errors. It's not that pricey. You can just, I also thought, okay, I need to think about it. I need to compare all the options, maybe a few days, a week. And then I just started getting the errors and doing all this feedback loop. It was an experience. Then I actually changed a few of my opinions.
Basically, you were doing reinforcement learning for yourself.
Yeah, exactly.
And learn the power of it.
Yeah, for sure.
Maybe we can now move to the coding agent topic, the main one. And you've been explaining coding agents for some time at the conferences to your team in Twitter. How would you explain what is a coding agent to someone who only writes code but doesn't know like how it works under the hood? And like what is the difference between different coding agents, like say OpenAI Codex, Claude Code, or Cursor? Like are they really different, or it's the same thing with just different labels?
Mm-hmm. Yeah, for me, basically, an agent is just an LLM with some tools that acts in a loop and can change its behavior based on some environment outputs. Like in the classic RL, an agent just works in some environment, and environment provides a state and a reward. But for me, the general agent is just LLM with the tools, and then we can talk about code agents. Most of the code agents that we are talking about, like Claude Code, Codex, Cursor agents, they're called like harness. It's just some engineering systems that is basically, in my opinion, then they differs in a set of tools. So example for the tool may be just list the files, search for some substring inside the content, run some bash command. Like bash tool is one of the most popular, I believe, the tools inside the agent, and they differ in some parameters, system prop, set of the tools. But I also need to say that we started our work in software engineering agents in 2024, June or July, and SWE-Bench back then they had just only Conda environments, no Docker images. So we built the Docker images. There was no something called SWE-Bench Verified. It was just a SWE-Bench with 2,000 of tasks. And they also released SWE agent, like software engineering agent. There is basically just a loop that iterates through the steps and have like tools search for some substring or run the bash terminal. And I believe that actually now we see how all the agents kind of converge get the convergence, because all the tools, they look similar, like they're basically the same. And it's not, I believe that it's not really necessary to change the right one. But there's also a thing called that if, for example, Anthropic releases Claude Code, it is it's very likely that they use this harness or scaffolding to train inside the RL. So I believe that their models will work best in this setup, and also they can use their own models, caching inside, better tools, and you can just get maybe cheaper the same results. But during these 2 years, we actually have seen a lot of agents, a lot of startups that just I don't know, raised $10 million to build yet another one agent, and now we see like the most popular ones just earn their market, and now we see not so many agents, I believe, that were in the SWE-Bench leaderboard 1 year ago.
So is it because the market is already overpopulated, or is it because like scaffold is not that important?
So the thing is that back in the days, we had models that were not so powerful and good with tool using. Because to work in the scaffold, you need to like generate a correct tool use template, work in the... Yeah, I will say this, that before, in pre-agentic era, most of the communications were simple question answering. It was single turn, not too much context, because like mean average like token count on some web page, like Wikipedia page, something like 1,000 of tokens. In the agentic loop, your context blown off, like 100,000 of tokens. And it's not single turn, it's multi-turn. And it may be very sparse because, for example, your actions are short and you have really big environment outputs. And it's not that easy for models to operate. So that's why we had something like, I don't know, 10% on SWE-Bench when it was released. And then every company just started using RLVR in the environments, and they're now quite good with the tooling. And now we see that, okay, for example, in Qwen3 Coder Next paper, I believe, they tried to do RL and benchmark with several harnesses and agents like MiniSway agent, Claude Code, and other ones. And they said that, yeah, okay, we have differences. So if you will use not natural scaffold or harness for the model, it actually, its power just drops. But I believe that for next releases, harness will not be so important, and we will have few agents from the major labs with their tools, and yeah, and it will be something like that.
Just to make sure, this scaffold and harness is the same thing or different?
Yeah. So for me, when I say scaffold or harness, it's the same thing. It is just a set of tools on top of the LLM, like system prompt plus the tooling, and I call it like harness. It may be Claude Code, Codex, MiniSway agent, SWE agent, anything, a cursor agent.
Do you use any of them yourself?
Yeah, actually, I use mostly I use Claude Code and Codex, like for some of my projects, and I also use another scaffolds like MiniSway agent, but with open source or open weight models, but mostly for the experiments with SWE-Rebench leaderboard.
Yeah, you mentioned several times the SWE-Bench verified, and I wanted to ask, like, these difference in numbers, like in 2024, it was just like 30%, now it's almost 80%, where it's coming from. You mentioned that the base models are being better and better. Maybe scaffolds are better, I don't know, tools are better, maybe something else.
Yeah, I think that we need to, at first I need to tell you about the basic example of the task from SWE-Bench for our listeners. So SWE-Bench is software engineering benchmark. Basically, each task just consists of one. It is some real world GitHub repository that is cloned and set on some base commit. And we also have some Docker image with this repository and installed dependencies, so we can run the tests inside them. Then we have some task description, like problem statement. It was taken from some issue from this exact repository, for example, with some bug fix or like feature request. Then we have some pull request that solved this issue. So inside the pull request, we have like git patch that is divided into two main parts. First one, we called it just patch. It's actually a part of the changes that solved the issue. And the second one is test patch. It is a test that were written to assess the solution and to ensure that issue was resolved. So during our benchmark runs and SWE-Bench, SWE-Rebench, any software engineering kind of task, terminal bench, we asked the model to implement this bug fix or solution based only on the problem description plus sandbox as the environment. Then we get the patch from the changes that model made and assess this patch with the test patches from the original pull request. It's like one example of the task. So you see here that model needs to work in multi-turn. So you have several steps, long context, work inside the environment. I think it was very like inconvenient and out of distribution use case in 2024 for the model. That is why they failed a lot. Then we have, like before working on software engineering agents, I was pre-training data lead in Nebius, and I was responsible for like large scale, something like 5 trillion of tokens data set that can be used for training. They should be like diverse, high quality, anything like that. And I believe that we had only one level of scaling, like how you will do your like model smarter. You either will scale your parameters count, either you will scale your tokens count, maybe some more high quality tokens or something like that. Then we had like in 2024 in December, I attended New Rips in Vancouver, and Ilya Sutskever had his speech back in the days there about that pre-training era is done. Like we can't really scale. We get only diminishing returns. We can't really scale the pre-training. We need to come up with something else. And then I believe like early 2025, we just get our next level, second level. It's something about post-training and scaling RLVR mostly. So I need to say about RLVR, maybe heard about like ChatGPT, maybe you heard about RLHF. So basically they trained the model, made an SFT to talk with people in question answering style. Then they used RLHF. Basically they trained a reward model on some aggregated human preferences, like here's 2 answers, you need to choose which one is better, and then use this to tune the model to some human preferences. But it still needed some expert labeling data, like human annotated data for all the stuff. Then we get RLVR, reinforcement learning with verifiable rewards. So the thing is that it mostly works for math and court domain because they are verifiable. So verifiable means that you can somehow assess and verify any solution. So you basically ask your agent or model do something, for example, fix some bug or issue in the repository, you get the solution and get the trajectory that actually leads to this solution. And then you somehow verify its solution. For math, you can compare answers and make an assumptions that if the final answer is correct, then all the chain of thought also correct. The next one, code. You can run the unit test inside the repository, you can run some tests and verify the solution. So it's also verifiable. When you have such verifiable tasks, you actually, even for like human annotated data, you don't need to come up with a lot of millions of tokens for SFT. You can just invest these human resources to come up with some tasks. Then for each task, you can generate a multiple solution, a lot of trajectories. And in terms of software engineering, they will be naturally long context because, as I said before, like each web page is just 1,000 of tokens. Here, you will get like 100,000 of tokens. They will be multi-turn with tool use, and they will be in the really high economic valuable domains like software engineering. RLVR works because now you can scale this lever. And I believe that in the next releases, major labs also will invest. They actually invest a lot of compute in the post-training phase in RLVR, and they will be spending even more compute in this second level. And there is, I think it's like similar, a little bit parallel level. Third one is about like test time scaling, because they came out in the same time. Test time scaling is basically that for each question, you can generate multiple answers or solutions, and then somehow choose the best one with some Oracle reward model, you know that, and you just your best of end result will be better than just some random one you can do like majority of it. Also, we get like third level of scaling, and I believe actually that the main answer is that in the domains where we can use RLVR, you can actually train a really great model for this particular kind of tasks if you can really verify them. That's why in the past year we have seen such like insane, mind-blowing increases in the software engineering and math problems. But I will say that I believe that now it only works for two domains in terms of verification. We have third one about factual domains, something like deep research, because you also can compare final answer, maybe something, and can do, it is called rubrics, when you use some LLM as a judge with a large checklist to assess the final answer and the solution. But actually, yeah, so RL works, GRPO, you don't need actually a reward model. Yeah, if you read a paper DeepSeek R1, it was a huge in early 2025. You don't need to use reward model. You actually just need a lot of diverse, high quality, reliable tasks with like, we now call it RL environments, yeah, reinforcement learning environments. That's how actually you can increase correlation. We had like, in 2024, in summer, we started doing our work in the software engineering agents. Then we moved to RL, and we actually have seen also large gains. Even with like a few hundreds of tasks, you can increase agentic tool use, software engineering capabilities for the model like insanely.
When the paper of DeepSWE, you know this paper, right? DeepSWE from Together AI, when it came out, like it showed that you can just run Qwen model and in the RL environment, and it will like double the score on.
Actually, we had the same paper. We have same paper. Yeah. We had the same research and experiments. Yeah, it's quite popular now. Yeah, you can do. And I believe that now, so one of our works about the training data set of such kind of software engineering task. And I actually believe that you can search for the like job positions of the contractors in RL environment startups and labeling companies to try to understand what our major labs are working on, in what domains. Because I've seen that now they are searching for like CUDA kernel experts, like, I don't know, Java 8 and COBOL experts in legacy systems, because it's really crucial for enterprises. And now they don't just use open source, like last Python version projects. They want to like go deeper in some other smaller and very focused domains.
How did you, as a person, as a team, decided that you want to, fix benchmarks for SWE? And as soon as you've made a huge progress there, what are other big areas, other big questions that you think are worth addressing Maybe you have some future plans, or maybe you see that the main question is there and somebody needs to do something with that.
Yeah, actually, it's a good question. So for software engineering agents, we just try, at first, we tried to do pre-training. Like I was pre-training data lead. We tried to, it was late 2023, and there are not so many open weight models, and we know that we can just scale the training and train better models. But then there were a very high actually barrier entry in terms of GPUs and GPU consumption. So we decided to move on to some more focused area, just do something else. And we thought, okay, we can do something with software engineering. And we tried SWE-Bench, but a SWE-Bench had only 20 tasks in its dev split set, just 20 tasks. And we thought, okay, we need to train our, fine-tune some frontier model and get better results, but we need some training data. And then I started my research into RL environments and the pipeline for software engineering tasks. And I thought, we don't have too many contractor labelers. We actually, and also I thought about the bitter lesson. You need to come up with some solution that is scalable without human manual work, because SWE-Bench was mostly manually annotated in terms of installation configurations and tests. And I come up with some solution to actually, we can use open source data, try to filter out some tasks and try to build them. There is a thing called GitHub Archive. It is basically an archive of all the public events on GitHub. And we just don't want to deal with the GitHub API limits. So we have a really great actually data platform and the product called Tractor.ai based on YT's open source project. It's really great for building the MapReduce jobs and do such things. So I use GitHub Archive and GitHub to collect a really large amount of Python repositories, issues, plus pull requests, then join everything. Then I thought, okay, we can do something with LLMs. Maybe they can understand without using agents, just based on the README and some list of the files, content from the, make file or requirements.txt, how to install this repository and its dependencies. Then, using this recipe, I try to run its sandboxes to build the Docker and run the test and do the execution validation process in SWE-Bench style. And it actually worked. And we collected our first release, called SWE-Bench Extra, something like 6,000 of software engineering tasks, mostly on Python. We released it. We use it for training. And I get actually a lot of emails from Chinese researchers that try to use these environments, because back in the days, there are not so many RHEL environments and software engineering tasks, and they just use it for our own research. And then I thought, okay, maybe we can actually use the same pipeline to collect some fresh tasks. It was just a part of our research promo for they said it's called SWE-Rebench. Maybe we can just do a little table with the frontier model results on some fresh data. The main point was about decontamination, because if you will use tasks that just appeared after models release, you can make sure that they were not inside the training loop. So, and then my co-author Alex actually said that, okay, maybe we can do something on the regular basis. Let's do a separate project, because it sounds interesting. And then we just tried to do two things. First one is to release a large training software engineering, as they said, that's called SWE-Rebench, and also release a leaderboard. It was, I believe it was May 2025 that we released SWE-Rebench leaderboard with the frontier models. Most of the models actually get, we thought that, okay, we will find some models that actually were contaminated because they will have a higher result on SWE-Bench and lower result on SWE-Rebench. The only such model was Llama 4, I believe, but another models are seemed okay. And we released and started to just reuse the same language agnostic automatic pipeline to collect fresh tasks every month, and we are still working on it. I think that main challenges are, first one, about tasks quality is really crucial. It is one of the points in the OpenAI's paper. The thing is that when you use open source data and issues, like the usual process for developer is to, then you have some problem, you write the code. Then you just write the test that that covers, you get your current score, 100 on this code. They're not really thinking about tests, really clear test-driven development, about all the requirements for the solution. And when you collect all this data, you have three things. First one is issue description that were written by some person. Next one, original patch that solved this issue. And the third one is test patch that were written for the solution. You actually want for your task to be really reliable and verifiable. So your test patch will assess only the solutions that solve the initial issue, and they are not too narrow. For example, they are not just comparing some substring inside the error message in the raising exception that is not mentioned in the issue description, or they are not too broad, but you actually also need the problem description to be clear, to be specified, so it has all the necessary information for the agent. It is about solvability. And these kind of problems we'll try to address in SWE-Bench verified work. But even after that, there are a lot of problems with the issues, with the task, because you want them to be reliable, verifiable, and from the real world. You want them to be fresh, diverse, and I think that one of the main challenges that everyone's working about the task quality. The next one, I believe, also about the scale in diversity, because SWE-Bench verified is only on Python, SWE-Rebench leaderboard as well, Python, but we're working on that. But there are a lot of domains and areas that actually will demand for some specific skills, like CUDA kernels, for example, or enterprise project. Also, one more thing, like SWE-Bench, SWE-Rebench, mostly about sandbox with one Docker image. You actually can't run multi-Docker, Docker Compose, but most of the project in the real world are with, microservices with several Redis, Kafka, every database is running. You actually want to work for your agent to work in the multi-image cluster, handling all the mistakes and errors. And I think that two challenges for me. First one is about overall task quality. Second one is about harder and more complex problems.
I've just checked SWE-Bench verified and Rebench to check this idea that before then it was the same resolve rate. Now it's different. SWE-Bench has 80% and Rebench has 60% for the best models. So this, I suppose, this 20% come from the contamination.
Not only. It's actually, they differ in terms of distribution of tasks, I believe. We are now switching to the more harder problems, but still reliable and verifiable. So I will ask to mostly focus on models ranking, whether the absolute numbers. There are a couple of helpful statistics because we want for our benchmark to be really practical and valuable. That's why we report, for example, not only one number, but also some confidence levels. We report them. So basically for each model, we'll actually do 5 runs, then average them. And we also report statistics like token count and price, because it's really crucial to get the numbers on price per value And we're also really open to any feedback. So if our listeners have new ideas or questions, feel free to ask.
The main question from me would be like, how do I test my model?
Yeah, actually we have. Every month we upload all the tasks on Hugging Face. We also release all the Docker images, and we have a simple code example in our SWE-Bench fork that you can use to run the evaluation. And also, like if you heard about Mini-SWE agent, they also, like Mini-SWE agent can be used. They have in their main repository SWE-Rebench as well. And I also have added to OpenHands. It's a really popular code agent. They also can use SWE-Rebench images to test like your model. But we are working. Actually, we want to add an adapter for terminal bench task because it's really convenient, and I know that a lot of startups use this format. So yeah.
All right. Maybe since the version 2 will be released after we publish this podcast, you can also say like what will be the difference with the new version coming.
Yeah. Actually, we're going to release SWE-Rebench V2. It is basically also the main. I think the core contribution is about language agnostic large-scale pipeline for software engineering task collection. And that's how we use this pipeline to collect even more tasks. SWE-Rebench V2 first release will be about the training dataset as well, because SWE-Rebench was something like 20,000 of Python software engineering tasks, and SWE-Rebench V2 will be 30,000 of higher quality software engineering tasks in 20 programming languages. And we also release Docker images, and we also release metadata about the tasks quality that we assessed. And we also release additional dataset of more than 100,000 of software engineering tasks based not only on issues, but also on the pull requests. So we use pull request to somehow generate, we use problem, like pull request description as the problem statement, also a generated one. So this kind of tasks also can be used in the training. And then we also have some upcoming releases in terms of the SWE-Rebench leaderboard as well. So we'll think about adding new languages, new kinds of problems, and everything like that, because now we have our language agnostic large-scale pipeline, and we can collect any software engineering problems.
I asked you in the Telegram channel once, like, will the Kotlin be?
Kotlin will be. Yeah. Kotlin will be
great.
one of them.
Any hints, like, is it a good language to do AI or not? I mean, like the numbers.
So it's like JVM based language. I believe that actually we get a lot of pain after switching from only Python to multiple languages, because you have like compiled languages, interactive languages. Every language has its own tool chain and package managers and stuff like that. And you also need like a reliable test results, in terms of that if you will run the same test command, you will still get the same like test names, test structure, and the result. And Kotlin JVM-based languages are okay. And I believe that Kotlin, Scala, Java, and others are actually quite good. The main like pain languages were C++, because like every project has its own like makefile and test running scripts. They're not really standardized. And maybe also with some long-tail distribution programming languages like OCaml, Fortran, Lua, or something like that.
One thing that is changing for developers when all these things are really moving forward is that work is changing from writing code to reviewing code, and Rebench is much more like automating the main part of this work. Have you thought maybe on something to do with the reviewing code and somehow address these new challenge for the developer community?
Actually, there is such thing called like verification tags, and now we spend same amount of time not for writing but for reviewing and coming up with like new ideas. Yeah, I think that we thought about the reviewing part as well, but I just you need just to come up with the solution how to verify the reviewing part, because reviewing is mostly about also we can come up with some kind of task when you just inject some bug inside the pull request, and then you know that there is bug and it will need to be catched with the reviewer system. So we actually haven't done any experiments in this field, but I think that we will see a new benchmark on the reviewing as well, because there are several domains like SWE-Bench like tasks at this moment, mostly like 80% of them about just bug fixing, 20% about feature requests maybe, but we also have a really large parts of software engineering work, like writing the tests, like test writing. It's really crucial part, reviewing the code, maybe building the architecture of the project. Then also DevOps, like infrastructure pane. It is like crucial parts of building really great agents. So yeah, I think that we will see, but we are mostly working with SWE-Bench like tasks, but we are moving to like feature requests and feature development as well. And we actually have statistics about tests, because as I said before, you have patch and test patch, and you actually, if agent wrote some like tests, you can use their test and use the main like golden patch to assess the test, because the test should be failed before applying the original patch and pass after applying. So you also can make an assumption that, okay, this test was correct. And we think that we will also release and share some insights on the test writing as well.
It's nice to understand that there is like tripod of issue description, patch, and test, and like you can generate any of those having.
Yeah, exactly. Yeah.
About reviewing the code and everything, maybe like running the code in the RL environment in the sandbox is another answer how not to review the code, just like run it several times and see if it's working. And for this, I wanted to ask about another project that your guys releasing. It's contree.dev, right? Can you tell about this one?
Yeah. So basically all the projects that we release, they came up from some of our problems and our work. So we had some experiments with searching, like MCTS, with search strategies. We actually had a paper at ICML, I believe, about the guided search strategies in the software engineering agents, where you basically can just generate several solutions for a problem or several actions on each step, and then use some reward model, critic model to choose the best one and do like not very complex, it's just one-step search, but you will get like better results on the problem. And with software engineering agents, there is a thing that actually, if you want to do some complex search strategies like beam search, MCTS, you actually need two tools. Like first one is the ability to roll out to some point in your trajectory, like some checkpointing. And the next one is about forking. So in each state, you can do several forks and then just continue your search strategy. And with like Docker and software engineering projects, there is a problem that some actions actually will not be invertible. Like, for example, running some command that will generate a lot of files and maybe change some roles or dependencies, and you actually need to start from scratch and just apply every step. So there is a project called Contree from our engineers at Nebius that addressed this problem. It is basically a service that can do forks inside the virtual machines for file system, and also can do checkpointing. And it's really helpful, in my opinion, for search strategies, because it is much faster than just doing from like first step. and it's more convenient. It also has Python SDK, and now we're exploring for new areas where we can use this agent. So one of them may be something like safety RL environments training, because if you have such opportunity to do a checkpointing, you can do anything like a RMRF on your root directory and just roll back to the step. So we can try something else. And also we can use them for computer use agents, because if you can generate a lot of trajectories for computer, like you've seen this like hype around OpenClaw, and I think that computer using agents will grow big in this year as well. So we need such tools to. My idea is that if we will develop the tools that will help the infrastructure or the open source, it will be compounding growth. So we will help each other and will get better results in the end.
I have like multiple questions from this point.
Yeah.
This project, right, Contree, will it be for the inference or will it be for training, like how people will use it?
It basically will be a tool. Now we just released in like pre-alpha release. So if you want to try it, please also feel free to write us. We're exploring. One of the use cases is search strategies for software engineering agents. That's how we use it. Also for training and inference as well, because if you want to do search strategies, it may be a better idea to do the RL training as well in such cases. And the next one is about trying on the inference side for software engineering agents maybe, but in the domains where checkpointing and fork mechanism will help with something.
Oh, okay. The next question would be, you mentioned Python SDK. You use, how does it work? I thought you checkpoint on the Docker level.
Oh, yeah.
Because
no,
you can do RM.
Yes. Python SDK is just a user interface, so you can just programmatically, it is like projects. If you heard about Model, for example, you can just write a Python code. Okay, build me like a sandbox based on this Docker image from the Docker Hub or Docker file, and then run this list of commands and do the checkpoint. So it's just an interface that can be used.
And inside it's Docker checkpoints, right? Or something.
So yes, the thing is that it's a virtual machine. So it is like Docker engines, because in Model they have virtualized some states, and it's not really Docker. So you will get the benefits of truly forkable mechanism and state. So yes, you can just think about it as the isolated sandboxes, like Docker containers inside the Kuber that may be forked and checkpointed. All the layers, like with all the layers, yeah.
Yeah, got it. The funny thing that I just implemented, not Docker containerized, but implemented tree search within SWE-Bench, like empty Markov decision tree search. But I did it with GitHub.
It's same idea. Yeah. Like GitHub, but more like.
And how like since I use Cursor, they have like multi-agent, multi-run, solve everything. They also have the checkpoints, so I can like click on any step and say like, okay, from this part do something different. Like how do they implement it there?
I think that mostly they implemented this through Model and Model interfaces. So they also have the checkpoints. That are not so stateful. You can't really, I believe that you can't really checkpoint. I mean, they for sure need to some infrastructure to checkpoint for all the steps, but I believe that they can't really checkpoint any step, because there are some commands that can actually fail your environment. So I believe that they do maybe start from scratch solution to come up to the checkpoint for some cases, but not sure.
I think you're talking about agents that run in the cloud, right? Because like in my local folders, I don't think there is like actual checkpoints. I usually see a GitHub, not GitHub.
Yeah. Yes.
So it's just messing with my like local file system and doing diffs back and forth. Nice. We'll be happy to try this one actually.
SWE-Rebench was a huge success. How does it feel like to have a project that is so well received, praised by the community? How does it feel to be one of the people who is responsible for such an important thing in the field?
Yeah, actually, I'm really glad that Rebench had its success, because like our main goal in the research and development team at Nebius is research and release everything in open source. I still believe that we can push the frontier and the edge with the open weight models in some domains, and they may be really helpful for some use cases and cheaper. And with the SWE-Rebench, actually, when we released, we didn't think that it will be like a large success. And after release in May, we just wrote on some our like X and LinkedIn. And then in June or July, I came up with the idea maybe we need to post to Reddit, like subreddit called Local Llama. And we get like a lot of feedback from there, a lot of commentaries about the releases. And that was the point. Then we thought that, okay, it is really thing that may be helpful for the community, because we try to do it really clear, practical, and helpful. That's why we use like one scaffold to run all the models, report everything. And if someone comes with the negative feedback or some suggestions, how can we improve our leaderboard, we always try to do our best. But I will tell you that the Rebench dataset get a lot of downloads, and I think that in August or September 2025, it was 3 or 4 millions per month, mostly because of some research labs running their training at scale and using this data set. For the leaderboard, we also see just growth month over the month. I think that now, we have something like 2.5 millions of monthly visits on SWE-Rebench leaderboard, mostly because of the like several influencers post on X platform. And for us, it is crucial to be at the same page with the community. So that's why we're always listening for the feedback, trying to do more high quality tasks, run more models that are asked for. So yeah, our main goal is to help the community run the test. We actually really enjoy our work with the SWE-Rebench leaderboard.
What was the most interesting, so you're really listening to feedback. What was the most interesting and unexpected thing that you haven't thought about, that you really saw appeal from someone that really made you, reevaluate your work, maybe think of new directions? What did you learn from the community? Yeah,
actually we learned a lot. One of the direction is about tasks quality, because we have this feature on the website called Inspect. So you can see every problem, like original issue and pull request. And there is one influencer on X that actually spent a whole day to go through each task and address, and just assess all the test patch, issue description, and give his suggestions about that. We used it. And the next one is about model running parameters. I believe that because we, first releases weren't actually using caching, for example, and then we started reporting prices. And there have been a lot of feedback on, okay, can you please report also caching percent to get the better understanding? And I still believe that, in the multi-turn long context, agentic trajectories, it is really crucial to turn on the caching, because your prices will drop 5 times. And it is a really important point in making decisions and choosing the model for enterprises, I believe, because there are several providers on OpenRouter that are not using caching. And you can just, if you will use the main model provider and they provide caching, you actually get like better results, faster results. And two main parts from the feedback were like task quality and like just running parameters, caching and something like that. Yeah.
Yeah, nice. I also like noticed that even the models that are run by OpenAI and uploaded to, I suppose it was run by OpenAI, or at least with the communication with the guys on and uploaded on SWE-Bench, they still do not use caching sometimes. So if you like check the leaderboard there, like the prices could be quite different. I wanted to ask about the, like, since now it's standing out benchmark data set, maybe you can also say about the competitors, because like in this paper from OpenAI, they say use SWE-Bench Pro. Yeah. What is the difference? Why I should use Bench Pro and not Rebench or otherwise?
Yeah. So the thing is that after SWE-Bench came out, we had several releases with the same methodology. There have been releases like SWE-Bench test, or they were like assessing the test patches, and we had like SWE-Bench Live or I'm not sure about. They also tried to do like updates on their leaderboard, and we also get SWE-Bench, SWE-Bench multilingual, SWE-Bench multimodal with another domains. And SWE-Bench Pro is work from the Scale AI. It's a major like labeling company, and they hired 100 software engineers to better address task quality. And so the main problem with the contamination is that actually you want your models either be from the private repositories, either be like in SWE-Rebench fresh, so they not be inside the training loop. SWE-Bench Pro has two splits. First one is public and private. In public, they have something like 700 of tasks, multiple languages. They have done a lot of filtering, and they also added something called requirement and interfaces to their problem statements to address the problem with too narrow test patches and underspecified issue descriptions. But actually, it's the same SWE-Bench. And SWE-Bench Pro, it is a static benchmark. And I believe that, and that's what we are pushing in SWE-Rebench, that actually you need a really dynamic benchmark if you want to like assess the quality honestly and just be sure that is a decontaminated benchmark. And I believe that with some filtering pipelines and work with the community, SWE-Rebench may be something even better like SWE-Bench Pro, but dynamic. So there are a couple of the overall format of SWE-Bench like that. Then you have some tests and problem description, and sandbox is really convenient and cool. And I think that may be used for several use cases, and we will see even more benchmarks.
Yeah, interesting. I also wanted to ask, like, why. Like you were talking about that you work like with the community, you try to publish everything that you research. I was wondering why Nebius actually does have a research, and why do you publish everything? Because like Nebius is a primarily cloud infrastructure, and how do you understand this mission from the inside?
Yeah, so just to give a little bit more context for our listeners, Nebius is an AI infrastructure company listed on NASDAQ that provides GPU cloud computing and AI developers tools to help businesses to build like AI products. It's a great company, and we have a small research team inside, mostly working for, we have a project called Token Factory. It's an inference platform, so training the speculators and building better inference. Part of our team are doing research and do the papers for like NeurIPS, ICML, and other conferences. with the main research idea in the field of software engineering agents. And the thing is that I believe that R&D really helps Nebius with one is some kind of credibility, because when you are selling GPUs to the research labs, when you say that you actually have an internal research lab with the same requirements and running the same really huge workloads, it will be better. And we always assess and test new clusters, new products, some kind of dogfooding that we're helping with to the Nebius. So first one is credibility. Second one is just some kind of new contacts, because we do several collaborations with the companies that later can become just our clients. The third one is about some kind of marketing in promotion, because we can push through the open source, and a lot of folks from the Reddit local llama, for example, will learn about our inference and GPU. And I also believe that when you're working in such competitive area like AI, even if you're an infrastructure company, it is crucial to have some resources and the people that are grinding in the research side to just stay at the cutting edge and understand what is the most capable technologies to work with now, and maybe to make some predictions for the future.
Yeah, actually, it's the same for JetBrains. Can I take this message and just use it next time someone asks me? Yeah. Maybe we can talk also about some future, because these years, AI coding is changed everything. And will AI replace programmers? Will there be more programmers, but some different programmers? And since you're working with the models and you know how dumb and stupid sometimes they are, what will never change? I don't know. What should we expect in 1, 2, or 3 years forward?
Yeah. So I need to do a little bit disclaimer, because I'm not that good at predictions. For example, in late 2021, I said, okay, GPT-2, transformer architecture, they're really dumb. We can't really do nothing with language models. Maybe I think I need to switch to something like recommendation systems or something near with money. So that's why I changed my job position. I started working in a small startup in some blockchain, doing recommendation system, product analytics, a lot of mostly hustling startup research. And then in 2023, then I joined Nebius. I had a talk with my supervisors, and we were talking about coding capabilities for large language models. And I said, oh, we need, I don't know, at least 10 years maybe, so the models will write some decent code. I think that we need something, but the area was really accelerating really, really fast. And now I believe that we will get future improvements in the domains that are verifiable, like math and code, up to the complexity where we can build challenging but verifiable and reliable tasks, maybe that are solvable by humans. I'm still not sure about the domains like creative writing, because they are not quite verifiable. And I still believe that with the maybe creative poems, I know it may be more problematic than RLVR. But just look for my disclaimer. I'm not that good at predictions.
Maybe something about medicine, since you came from
maybe
that field, and
actually
you wanted.
Yes, biotech. Yeah, I still believe. Yeah, one thing is that actually there are a lot of companies that can get benefits from the computer use and general agents. Something really dumb, like doing logistics, receipts, just sending with some CRM, and it may be really helpful. And the healthcare, they have a lot of legacy systems, a lot of bureaucracy. And if we come up with some reliable systems and LLMs, I believe that we have a lot of projects that are working on the cure for the cancer or really complex and hard diseases. But maybe because of my background in healthcare management and public health, I believe that you get a really huge social impact if you will use AI and all the systems to help the bureaucracy and healthcare for the insurance problems. I don't know, all the managing side. I believe that it will be very beneficial in terms of social impact.
So you've already switched your trajectory once, and now you're basically, in a way, working on like if everything goes. It's hard to say that it's good because it's a very strange future. But if software engineering and machine learning is solved, what would you do?
I will go back to dentistry. I will go back to dentistry. I will just pass my certificate and exams because I have a lot of friends that are working as dentists, mostly in the implants or orthopedics. They earn a good amount of money, and it's really, I'm not sure about robots in this field for like 10 or 20 years. So I will just need to maybe do some rehearsals and to just remember my skills, and we'll go back to the dental office.
It will be fun to check your resume. This resume about the guy who went from Microsoft, like head of something, to just farming.
Gardener.
All right, this is it. Maybe I don't know. Maybe the final question, so we can conclude. So imagine I'm a dentist right now and I want to switch my profession. Like where should I go? What should I do? Is it AI? Is it something else?
I still believe that it's not about some domains like AI or dentistry. And I believe that if you will gain some meta skills that were like over the level of just some practical experience, something like learning how to learn, or about how can you decouple some challenges, how you can communicate with people and maybe solve and think about complex problems, it will be very beneficial. And also about how can you use like AI or code agents to help you with your like routine work, it will be very beneficial, and you can work in any domain and just get the value.
Thank you. So let's conclude. Thank you for having us. And
thank you.